Hola, Team Bio! Remember when I said yesterday was your last screencast? Well, that was a lie. This is actually your last screencast. Okay, so this screencast is on X-linked genes, and the first thing I want to do is throw up two karyotypes. 1 second. Okay, so here's an image of a human female karyotype and a human male karyotype, and you'll notice that they share a lot in common. They all have 23 sets of chromosomes, but the things that makes male and female different is the sex chromosomes that we have. So females have 2 X chromosomes, and males have 1 X and 1 Y. Now, the X chromosome has lots of genes on it, not just genes for being female, but for example, the gene for the photoreceptor to distinguish between red and green is located on the X chromosome, and the gene for a clotting factor in your blood is also on the X chromosome. The only genes that are on the Y chromosome, you'll notice it's really tiny. The only genes on that chromosome are the genes that make someone male. So they turn on during embryonic development, and they basically start the development of male genitalia and the testes. And so if you don't have a Y chromosome, if you're just a single X chromosome, you will be phenotypically female, meaning you will have female genitalia. You will be a sterile female, but you will still be female phenotypically nonetheless. Okay, so sex chromosomes decide our sex. And again, women are XX and men are XY. So I'm just going to write that here. So if this is XX, this is going to be a female, and if this is XY, then you are going to be a male. So if we were to cross a person who, oh, that doesn't look so great. I'm going to erase these actually and just draw them a little bigger. XX and XY. So if we cross someone who's female to someone who's male, we can make our typical Punnett square here, and XX are the two alleles that the female can pass down, and XY are the two that a male can pass down. Oh, whoops. So you'll notice here, in my Punnett square, I have 2 XX's and 2 XY's. So there's a 50% chance of being born a girl and a 50% chance of being born a Y. All males get their father's Y chromosome. All males also get a chromosome from their mother. You'll notice that right here. All females get the X chromosome from their father, because he has one too. So if you're a female, one of your X's comes from your mom, one comes from your dad. If you're a male, the X always comes from your mom, the Y always comes from your dad. Okay, so I think that is relatively simple, makes sense. 1 second. I have Darren Chang.
You're still connected to the Apple Tap iPad too.
Okay. I'm connected. I'm projecting what I'm drawing here, so I'm going to undo that. Okay, I have unplugged from AirPlay. Okay, so as I said before, that the X chromosome contains genes on it that are not just coding for sex. For example, the gene for the photoreceptor that determines red-green color blindness is also located on the X chromosome. So imagine we have a woman. If she is X big R, that's the normal vision. And X little r is going to be equal to red-green colorblind. Okay, so these are our 2 alleles. Now, if we have a woman who's X big R, X little r, she has normal vision. Even though she has 1 copy of the little r allele, normal vision is dominant over colorblind, so she sees normally. However, a man only has 1 copy of the X chromosome. So if he has a little r copy, he is going to be colorblind. So if we look at these people, she is not colorblind, he is. Let's look at their offspring. So X big R, X little r, X little r, Y, so here. Okay, so for these people, you'll notice if we have a heterozygous mom and a dad with the disease, it means he will pass on the little r allele to all his daughters. And the mother passes on her little r allele to half her offspring. So here we have one affected boy who's going to be red-green colorblind and one affected girl that's going to be red-green colorblind. Okay, let's look at a second scenario where neither of the parents are affected, but the mom is a carrier. So she's X big R, X little r, and the dad is X big R, Y. Then the offspring will be okay, so looking here, we've got an unaffected female right here. This female is also unaffected because she has one normal copy of the allele and one colorblind allele. This male is affected, or unaffected, he's got the big copy, but this male right here, the son, is affected. So you'll often hear people say that men X-linked genes present themselves in men more. Well, the reason for that is because they only need one copy of the allele in order to show the phenotype. So, in this family, none of the daughters will be colorblind, but 50% of the boys born in this family will have colorblind, or will be colorblind. Okay, I could go through more examples, but I think you guys get the gist of what's going on here. Yeah, so this is it. This is the very last screencast I promise of the whole year. Okay, I'm going to pause and upload this right now.